Welcome to your second lesson. This is 1.2 Arithmetic Series. So the previous lesson was all about arithmetic sequences, so patterns of numbers, and that's where we stopped. We said it could go on infinitely. They increase by the same amount every time or decrease by the same amount every time. Now we're getting into series. So series is different than sequence. The definition, let me zoom in here a little bit so it takes up your screen. The definition of a series is it's the sum of the terms. So an arithmetic series is the sum of the terms in an arithmetic sequence. So going back to that first example that we had for the sequence 2, 4, 6, 8, ... The arithmetic series is 2 plus 4 plus 6 plus 8 plus ... So for the arithmetic series above, the sum of one term is just the one term. So sum of 1 is 2. The sum of two terms is you're going to add the first two terms of that sequence. So term 1 is 2, term 2 is 4, which means your series of the first two terms is going to be 6. For the third one, we do the exact same thing. So term 1 is 2, term 2 is 4, term 3 is 6. And I know that that sounds a little weird in your head when you're thinking term 1. So we've got already got a number associated with it, but now we're putting in something else. Okay, so be careful. 2 plus 4 plus 6 is going to be 12. So we've got 3 different solutions depending on the series and the number of terms. So we need a general way of figuring that out no matter how many terms we're dealing with. So the sum of n terms needs a general formula. So for the arithmetic series with the first term as t1, the common difference is d, so that hasn't changed. The nth term is tn, and the sum of the first n terms is called Sn, or the sum of n terms. And we write the equation like this. So we've got option 1 does not include your common difference. Option 2 only includes your first term, but it does require your common difference. So you're going to use each of these equations differently depending on the scenario. So again, T1 is your first term, T2 is your second term, etc. So Tn is the nth term. So we've got our first example here. Determine the sum of the first 6 terms of the arithmetic series. Oh, and you know what? We've got 25 plus 14 plus 3 minus 8 minus 19 minus 30 minus ... Never forget the ... I know it seems silly, but you need to use it because that is going to keep going forever. So the first thing we need to do, well, if we wanted to use the second version of the equation, we would have to figure out our common difference. Our first equation, though, doesn't need the common difference, so we're going to use that one, because if we can take fewer steps to solve a question, then why wouldn't we? So just like the previous lesson, I always want to start by writing out my equation. So switch my pen. Sn equals n t1 plus tn divided by 2. Okay, and off to the side, I'm just going to fill this in. identify my variables. So T1 equals 25. T6 is what we're looking for. The sixth term is going to be our last one, and that is negative 30. And then n is 6. So from here we plug and chug, Sn equals, and now it's not Sn though, it's S6. 6 multiplied by 25 plus negative 30, so be careful there, and divide by 2. A couple different ways you can think about this in terms of mental math. I always like to try and reduce things whenever possible, so 6 can be divided by 2. So I'm automatically going to write that as 3 instead. 25 plus negative 30 is going to be negative 5, which means the sum of my first 6 terms in this arithmetic series is going to be negative 15. There you have it. Done and done. So let's try another example. Okay, so an arithmetic series has term 1 is 3, and the common difference is negative 4. Determine the sum of the first 25 terms. So you would not want to have to go through and write out all 25 terms and then punch them each individually into your calculator. That is insane. It's going to take you too long. So we have an equation that will work much quicker, at least once we get the hang of it. For now, we're going to take it slow. Which equation are you going to use? Well, we have term 1 and we have our common difference. So we're going to use the equation that has term 1 and our common difference. I'm not going to use the one that has term 25 in it because I don't know what that is and I'm not wasting my time figuring it out. So in this case, Sn, again, write the equation. Always write the equation. We've got Sn equals n 2t1 plus d multiplied by n minus 1. Oh my goodness, so massive. But don't worry, it just looks like a beast. It isn't actually that crazy. So we've got term 1 already identified, d is already identified, and n is already identified in the question. It's 25, so we can start plug and chugging right now. 25 multiplied by 2 times 3 plus negative 4 multiplied by 25 minus 1 all over 2. So that looks a little ugly. Let's solve some little pieces in the meantime. So we've got 25 multiplied by 6 plus negative 4. And again, you can do these in fewer steps. I'm not showing your work for all of it, but I'm going to do it piece by piece. It's going to be 6 plus, oh, and it's not going to be plus. Watch your signs. Subtract 4 times 24 is 96 divided by 2. And that's going to be 25 multiplied by negative 90 divided by 2. Again, because I'm doing mental math here, I'm going to try and reduce these numbers as much as possible. 2 goes into 90, or negative 90, negative 45 times. Because I'm going to need to keep writing this, I've run out of room. S 25 equals 25 multiplied by negative 45. Now I'm not doing this one in my head. Give me a second. Let me find my calculator. And we'll figure this out together. 25 times 45 equals 1,125. So that seemed to take a long time, but trust me, if you are quick with your mental math skills and you can skip a whole bunch of steps, you could probably skip most of this and jumped right to this point here of 25 multiplied by negative 45. And what am I missing actually from my answer? That negative. You will find that integers are the bane of my existence. And I'm always forgetting them, but I always do check my answers, so that makes sure that I don't actually end up with the wrong one. So watch out for those integers. They're out to get you. Not actually, but sometimes it feels like that. So example 3. An arithmetic series has, let me move this just ever so slightly so I can see, has a sum of 93.75 and a common difference of 0.75, and term 15 is 11.5. Determine the first 3 terms of the series. Okay, so challenge. What are we going to do when we don't have enough information to complete technically either of the equations we have for determining this arithmetic series? Answer, we need to go back to yesterday's or the previous lesson. Maybe you're watching it today too, if you're keener. You need to go back to yesterday and we need to figure out how can we determine term 1, because that is showing up in both of our equations for figuring out the series. So we go back, and yesterday we learned that Tn equals T1 plus Dn minus 1. Okay, well, we have enough information that using the values in our given question and this equation, we can determine term 1. Once we do that, then we should be good to go, actually. Alternately, you could use our series equations and work backwards from either one of them. Just a second here, let me find those equations again. And T1 plus Tn over 2. So all 3 of these equations are going to let you solve for term 1. It's just a matter of what you want to do. So I'm not going to use our first equation. That would probably be the easiest option. But since we did that yesterday, I'm not going to worry about it. You can do that one if you want, because we are given our D and term 15. But I'm going to show you how to manipulate these 2 pieces here. I'm going to use the most complicated looking one, the one with the most brackets, the one with term 1 and D. You can also work backwards from the one involving term n, but I'm going to choose this one because it's the craziest looking, and so if we end up having to do it, I want you to have something to look back on. So S15 is 93.75, just to make sure that I have everything. So n is 15. Term 1 is what I'm looking for. And I also need D, which is 0.75. So I'm going to plug in chug. Oops, I'm not doing that. We are doing, sorry, 93.75 equals 15 times 2 times term 1 plus 0.75 multiplied by 15 minus 1, all divided by 2. Now I can get that 2 out of here right away and multiply by it. And I'm going to use my calculator again. 93.75 times 2. 187.5 equals 15 multiplied by 2 term 1 plus, and I'm going to do 0.75. And 15 minus 1, I'm going to do that at the same time as 14. All right, now the next thing I need to peel away, working my way into term 1, the next thing that's farthest out is that 15. It's currently multiplying, so to move it, I'm going to divide by 15, not by 12. Don't know where that came from. So now we have a much less scary number. 12.5 equals 2 term 1s, and I'm going to multiply that 0.75 by 14, which is 10.5. From here it looks like a linear equation, a little bit more manageable. Subtract 10.5 from both sides, so that cancels out, goes to 0, and we're left with just 2 term 1s. And 2 on this side, divide by 2 to get term 1 by itself, and that leaves me with 1. So term 1 is 1. Am I done? Go back to the question, and I am looking to determine the first 3 terms. So I'm not done yet. So term 1 is 1. Term 2, how do I figure that out? Well, I add my d value to term 1. So 1 plus 0.75 is 1.75. Term 3, I'm going to add that 0.75 again, and so that's going to leave me with 2.5. And there is my answer. You are not done until you have all 3 of those terms, because that's what the question asked for. Next page. The bottom row in a trapezoid has 49 cans. Each consecutive row, consecutive means the next one, the one directly beside it, had 4 fewer cans than the previous row. There are 11 rows in the trapezoid. How many cans were in the trapezoid? So we've got 11 rows, and we know the first one is 49. Oops, sorry. What's going on here? There we go. We've got 49 cans. The next row has 4 less. So what's that going to be? 45. All the way until we get to 11 rows. So 49 is going to be term 1. 45 is going to be term 2. That 4 fewer is going to be our d value. So those are some of our key pieces. Oops. So D is not just 4, but -4 since it's decreasing. And if we read the question, how many cans are in the whole trapezoid? Not just one row, not in the 11th row, not in the 5th row, but the whole darn thing. So we're going to have to add up all those rows together. So we're talking about a series, not a sequence. So we need to decide, what equation are we using? Well, we've got one equation, involves term 1 and term 11 in this case. Do we know term 11? No, we don't, so we're not going to use that one. Instead, we're going to use the equation that looks a little monstrous, but it has only information that we are already given. We're given the 49 cans as our term 1, and we're given our D value of -4. So here we go. Start by writing the equation without filling anything in, because that's how we get it to stick and make sure we don't make mistakes. So give me a second while I write it down. Divide it all by 2. Now I can start plugging in. So we're looking for S11. So it's going to be 11 multiplied by 2 times 49 plus -4 multiplied by 11 minus 1. All divided by 2. 11, we've got 98 plus -4 multiplied by 10. Again, feel free to skip as many steps as you want. That can even be a round bracket now. Going to be subtract 40, watch your integers. Now again, I like reducing my numbers and dividing as soon as possible. Excuse me. So we've got 58 divided by 2, so it's going to be 11 times 29. I'm going to use my calculator for that. That gives me 319 cans in the trapezoid. And there you go, lesson 2, all done.